receive, transmit. Now, does this make sense? Because now when PC is transmitting, guess what PC2 is doing? He's getting PC1's wire or transmission on his receiving end. That makes sense. But remember, these network cards are all built the same. So we can't just... I mean, the only way to do this is really to go into the network card and actually change the pins around with circuitry and stuff like that. Or we can be a little bit less hardcore like that and change our cables. Because we know this is transmit, this is transmit, this is receive, and this is receive. So instead of us going in and trying to make changes to the network card, leave the network card the same. And let's take our cable here. And let's take one of these transmits and bring it over to one of the receives. One of the transmits, bring it over to the receive. Then we take one of our receives, bring it over to the transmit. One of our receives, bring it over to the transmit. Now this makes sense. Now one of the things you also have to realize is this. I'm dealing with electricity. So since I'm dealing with electricity, what do we need for electricity to work? Positive and negative charges. So as you can see, this is why I have two transmitting cables. One's positive and one's negative. Receive, one's positive, one negative. Now the problem with this is, remember what happens if you take a negative charge and tie it to a positive charge. Now if you don't know this, that's fine. You know, I know this from my electrician days, and of course when you learn physics, you learn this as well. Okay, when you take a negative charge and tie it to a positive charge, what happens? It gets discharged. Whatever this is gets discharged, it shorts out, and you're done. So you got to make sure that your negative stays with your negative and your positive stays with your positive. Now, you can remember all this, get out your meter, try to figure out all this stuff is, or you could just remember the sequence. If this is pin 1, and this is pin 2, and this is pin 3, and this is pin 6, what are these? 1, 2, 3, and 6, right? So as you can see, 1 is going to 3 and 2 is going to 6. If you just remember that, 1 to 3 and 2 to 6, you will be able to make your crossover cable. These are the only two you have to remember. 1 to 3, 2 to 6. 1 to 3, 2 to 6. 1 to 3, 2 to 6. You don't need to remember 1 to 3, 2 to 6, 3 to 1, 6 to 2. That kind of gets, a little bit too much. If you want to memorize it that way, that's fine. But 1 to 3, 2 to 6. That's all I remember. I know on this side is 1 to 3, 2 to 6, and on this side is 1 to 3, 2 to 6. And now, because you have done this, you have crossed the cables from the transmitting side over to the receive side on the other end. Because remember, you're going to have a long cable here. You're going to have your RJ45 sitting here. You have this nice little thing going across. Your cable's going to come out of it. It's going to be a nice long cable. In here, you're going to have your RJ45s, and you got these pins sitting here. Okay? And on the other side of this cable, guess what you're going to have? Well, the same thing. So you got to make sure whatever's sitting on this pin, on pin 1, needs to be on what? Pin 3 over here. Whatever cable you're using. If you're using the green stripe here on pin 1, that green stripe over here needs to be on pin 3. Does that make sense? This will be going to pin 3. And you would do this with each one of these cables. This is what we call a crossover cable. Does this mean that you need to learn how to make crossover cables? No. Should you? Oh, absolutely. You should go out there and get yourself a cheap pair of crimps and make some cables, man. Doesn't matter if they're perfect. Doesn't matter if you cut them really long, and just do it to see how it works and see if it does work. So that makes me wonder then, because do I buy crossover cables for everything? Well, that's an interesting thing. Let's talk about that. Let's take a look at our PC here. I'm going to draw a big one this time. And let's take a look at our switch. Okay, so here's port 1, and here's port 2. I'm not going to draw the rest of the ports. This will be switch 1. Going into the switch port, I'm going to have an Ethernet cable, which means I'm going to have 4 cables. Technically 8, but we're only going to be drawing the 4. Coming from one network card to the other, I'm going to have, coming out of my PC, I'm going to have pin 1, 2, 3, 4. This is going to be 1, 2, 3. Sorry, not 4, 6. 1, 2, 3, and 6 are going to be the pins that I'm using to do my communication. Now, PC 1, he's going to have transmission up here. Transmission. We all know this. This is how all the network cards are with the PCs. He's going to have receive and receive. Now, I can even add the plus and the minus, and the plus and the minus, if I want to. But, however, do we use crossover cables going from a PC to a switch? No. We use a straight-through cable. Interesting. Now, if that's based on what you just told me, Kyle, is that means that if that's the case, there's no way this switch port, it's like your normal Ethernet ports. I mean, it's still an Ethernet port, but there's no way this communication happens unless this is a receive and this is a transmit. So pretty much, if I understood what you stated before, that means 1 and 2 from a switch will be receiving, and 3 and 6 will be transmitting. And that's exactly what will happen. That's why you can plug a straight-through cable into this switch. So that means your switch pinouts are different than your PC pinouts. Pretty cool. And that's how now you're starting to get an understanding how these cables plugging into these devices, how they work. Do you need to know this? Absolutely. You don't need to know it to this granular degree as far as a transmit receive, but you need to know what a straight through cable is and what a crossover cable is. It is important. The problem is when we explain these things, we just go through it quickly and that's it. And that's what is really important for you to understand exactly why we need crossover cables and why we use straight through cable. So far so cool. So that means if I am connecting two devices that have the same pinouts, what do I need? A crossover cable. If I have two PCs that have different pinouts that are relevant to my pinouts, now that's really important because I can plug this cable, this PC network card into a console cable, but it doesn't mean it's relevant. I mean, the jack might plug in, but it doesn't mean those pinouts are relevant to the point where I can transmit and receive and get data from it. You see my point? So plugging a PC into a switch goes together. I mean, it's like bread and butter, right? They go together. So if it's like bread and butter, obviously this pinout and this pinout have relations in some way, shape, or form, which means they're opposite, so those two can communicate. Now that we know what a crossover is used for, and we know the necessity for a crossover and a straight-through cable, we now know that all switches are set up to the fact that we can actually use PCs to connect to those switches with straight-through cables. Now, this is good to understand because we have to have some type of sense of when do we need a crossover cable and when we don't need the crossover cable. And really, all this down here is really just showing you the different types of pairs that we can use. Here's a standard A, here's a standard B. But as you can see, it's still the same concept. Still 1 and 2 are pairs. 3 and 6 are pairs. Here's our crossover cables. When we're just using 100 megabits per second. And here's our cabling when we're actually using 1 gig. Notice that we're using all 8 cables instead of just 4. So you mess up this type of communication, they're just not going to work right. So let's look at what happens when we have a certain device. Now, eventually you're going to learn the different types of devices that we have here. You're going to learn that our routers are layer 3 devices, which you're going to learn later on. You're going to learn that our switches are layer 2 devices. You're going to learn that our network cards are layer 3 devices. Our bridges are layer 2 devices, which you're not going to really get in detail with that. And you're also going to learn, which actually that's what we're just discussing now, that hubs are layer 1. Hubs are layer 1 because we don't use MAC addresses. So the fact that this says layer 2 is not correct. It's actually a layer 1 device. Now, as far as the bridge is concerned, we won't really be bringing that up again or the hub again, and most likely, but we'll be talking about layer 3 and layer 2 devices all the time. Nonetheless, the interesting thing is when we are connecting a router to a switch, remember the normal way to do this is pin 1 and 2 will be transmitting, while pin 1 and 2 on a switch is receiving. So anytime you're plugging into a switch, a straight-through cable would do just fine. Again, the key factor is you're going to need a crossover cable when the pins are matching up to be the same. So pin 1 and 2 are transmit on this side, and over here, pin 1 and 2 are transmitting. Yeah, you're going to need a crossover cable, right? But knowing what we know about a switch, we should be good to go. We can use a straight-through cable here. Not a big deal. Not a big deal at all. PC going to a switch, pins 1 and 2 will be used here. So no big deal. This will be a straight-through cable. Now, if the switch, if their pin 1 and 2 are receive, don't you think the other side, if you're plugging into a switch, pin 1 and 2 will also be receiving? So you would need a crossover cable here. If a router, pin 1 and 2 are transmit, don't you think the other side of a router port will be 1 and 2 will be transmitting? So that means you're going to need a crossover cable here. Starting to make sense? I think I lost my mouse there. Let's scroll this down. Hub to hub, yeah, you're going to need a crossover cable. I mean, you got to, somewhat common sense will be used here saying, okay, well, if I got two like devices, obviously I'm connecting a hub and a hub, a router and a router, a PC and PC. Obviously, the pins are going to be exactly the same. I'm going to have a crossover cable there. But a hub also has pin 1 and 2 as received. So having a PC plugged into it is no big deal. We can use a straight through cable. Hub and switch, both of the pins are received on pin 1 and 2. So we're going to need a crossover cable. And going from a PC to a router, this is one of the most important things because it's very easy to plug a PC into a router or a server into a router and forget that their network cards both have 1 and 2 transmitting. So because of that, we will need a crossover cable. So all the information we were talking about before, it gives you a better understanding of why these crossovers are needed. Not just memorizing what needs to be done. Okay? So let's talk about a little bit more fundamentals here. One of them is, what is an IP address? We're not going to get really detailed in addressing at this moment, but an IP address is an identifier. And that's all it is. It is a number that is used to identify a device on the network. So what does that mean? That means every PC, every printer, every wireless device, no matter what, if it needs to communicate with each other, it needs an IP address. So that means if I have a communication like so, this is going to have an IP address. This is going to have an IP address right here. Even my switch can have an IP address, but as I'm moving data from here to here, I'm not using IP to move that data. I'm not using IP addresses. So at this point, think of a switch as no IP addresses. Think of this as a underlayer passageway for my IP addresses at this moment. Switches work on what we call layer 2. Routers work on layer 3. And of course, your PCs, its net card will be layer 3. So think of that traffic leaving PC, layer 3 information coming into this switch.